right? If I'm not wrong. Windowing, segmentation,
Port numbers.
and
Port numbers.
yeah, port numbers. Just a moment. Port numbers, MSS as well. Then we are done with TCP three-way handshake. TCP four-way handshake. Then
You want me to like go on?
no, this should be enough. Yeah.
Yeah.
So these are under which layer? These are under layer 4, which is
Transportation.
transport. Not transportation. It's transport layer.
Transport.
Transport layer.
Okay. So now there's one important concept to understand. MSS is of fixed size, whereas window size is variable. Now the question comes, how is it variable exactly? I'll explain you with a diagram. So firstly, in order to explain this, I would like to take the example of parking lot. Okay. Parking lot. Shopping mall, for example. Okay. What happens is there is let's say this is one mall, device A mall and device B mall. Okay. Now, device B mall has the capacity of, let's say for example, 2000 vehicles. Okay. Now, device A mall has the capacity of 3000 vehicles. Okay. Now, in this, what happens is, generally people say that the lowest value is negotiated in between the two. But it is not like that. Actually, what happens is, as far as the window size is concerned, that is independent value of each individual device, meaning let's say you and I are exchanging our window sizes. I'm saying that my window size is 2000. You're saying that your window size is 3000, which means that if I send any data to you, maximum extent, I can send only 3000. If you're sending any data to me, you can send only 2000 to the max. This is what is exact meaning. Okay. So from the device A's perspective, device B can send maximum of 3000 bytes of data, not more than this, to device A. What happens if device B sends more than 3000 bytes? There would be a congestion, right? Buffer overflow and congestion. You know what is congestion? Congestion is like traffic jam.
Yeah, okay.
Okay. Just remember the congestion with an example of traffic jam. Okay. Now, so here, why I'm saying it as variable is a question. Why window size is variable? So the answer for this is very simple. Like the way I've taken the example of parking lot. Do you think parking lot is empty with all the 2000, meaning empty space of 2000 vehicles always?
No.
We can't say that, I think so, right?
Correct, right?
Yeah,
so
there may be another,
yeah, there may be any value between 1 to 2000.
2000.
2000.
So that is what I'm trying to mention over here. Hope you got my point, right? Now,
Mm-hmm.
for the first exchange, whenever he has sent any data, for example, A has sent any data to B, okay, of certain amount of bytes. Like I said, how many 4128 bytes? Usually I'm taking this example only to make you understand that it is not constant, it is variable. Okay. And not always the 4128 bytes is sent, it might be MSS as well, depending on the data size. Reason why he can send exactly based on MSS is, however, one thing to be understood over here between window size and MSS. In window size, what happens is only difference between window size and MSS is in terms of acknowledgements. In case of window size, after 4128 bytes is sent, then the acknowledgement comes in. But in case of MSS, after each and every 1460 bytes data is sent, you'll have an acknowledgement to be seen. But however, the sending and the segmentation remains same, which is 1460 bytes. Meaning what I'm trying to mention here is 1460 into what value is equal to 4128 is sent to device B
Okay.
at a time, group of segments. Meaning, for example, let's say we are talking about window size. In case of window size, what happens is individually 1460 is sent, that's for sure. 1460 segment 1, 1460 segment 2, in and so on up to the value of 4128. If you add this, you should get the value of 4128. Once the 4128 is done, you'll have an acknowledgement in this direction. Are you able to understand or any confusion?
No, I can
Yeah.
understand. Yeah.
Okay, this is what I'm trying to mention. So why window size is variable? Because of, you can take the example of parking lot. Okay. So between 1 to 2000, it may vary with any of the number in between this range. Okay. Initially, they exchange that this is my space, but depending on the data exchange, the space will be variable. But in in case of MSS, it's not like that. It's fixed size of division of data bytes. Okay.
Okay.
Now, so this was the thing regarding MSS. Now, let's see what is TCP header. Are you able to see this one?
Yes.
Okay. Now, so basically, if you see these values over here, okay, these are all called as flags in TCP. SYN flag, FIN flag, reset flag, push flag, acknowledgement flag, urgent flag. Okay, there are 6 types of flags over here. Okay, now whenever there is a TCP header, you have a source port, you have a destination port. From initiator, okay? Whoever is initiating the traffic or the data, from his perspective, the source port is always a random number, and okay. Now, what this sentence means is, for example, I'm requesting for a web service in layer 7. Okay. In this layer 7, if I'm requesting for a web service, what my source port would be in case of layer 4 is source port would be any of the number from 49152, for example. Okay. What would be my destination port for, let's say I'm using HTTPS. For HTTPS, the destination port is this one. This is for HTTPS. Am I clear or any confusion?
No, it's clear.
Clear.
The source port is random number. The destination port is well-known number, which is 443 for HTTPS. Now, you know what is sequence number, right?
Mm-hmm.
We are done with this. You know what is acknowledgement number as well. Now you know source port and destination port. Now, you know what is SYN flag. You know what is acknowledgement. You know what is FIN. You need to understand what is reset, push, and urgent. Okay. So firstly, if we talk about reset, RST flag. So reset flag is seen, for example, you have a PC, the same web server example I'm taking. You're requesting for a web service. In between, there is some router or a firewall. So this PC is connected to router, and this router is connected to a server. This server is called as web server because it is providing web service. This is a router and this is PC. So now, like the way I told, I'm sending my source port a random number, some random number you can assume. I'm sending my destination port to be well-known number. Let's say I'm requesting for HTTPS, so I'm requesting for the port 443. For example, if the port 443 is closed on this web server, okay, if like the way I told, if you remember, whenever TCP protocol is involved, in order to, before the data exchange, three-way handshake is initiated. Why? To establish a connection, right? So
Mm-hmm.
initially he'll send SYN message. So on behalf of this SYN, what should he receive for this SYN message?
Acknowledgement blessing.
Correct. So instead of that one, what he will receive is, he will receive reset. Reason why? You can assume this example like wrong number. Okay. You have dialed
Okay.
a number. You're asking for a person, but unfortunately it turned out to a wrong number. The same case. You're requesting for a person's name with this SYN. Okay. But unfortunately that turned out to a wrong number. So the person who has responded to the call is saying reset. Understood?
Okay.
Why is saying reset? Because this port number is
Port is
closed.
yeah.
So if it is a web server, actually what happens is this service should be running. HTTP as service would be there on the server. Stopped or closed. Okay. Hence it is sending reset message. Is this thing clear or any confusion in this?
No, it's clear.
Clear.
Okay. Now we are done with reset as well. Okay. Now we'll see what is push and what is urgent. So yesterday I've discussed something, if you remember, uh, what I told by default, any device will have a buffer memory, and until and unless that buffer is full, that particular device will not process the data, right?
Yeah.
So in this case, if the push flag is enabled, then what happens is, please push the data irrespective of the buffer is full.
Okay.
Okay. So if push flag is enabled, okay, this means push the data as and when it is arrived immediately without waiting for the buffer to be full. Okay. Am I clear?
Yeah, it's clear.
Yes.
Okay, fine. So this is all about push flag. Now, what is urgent flag is, for example, if I'm sending urgent, it is just like an ambulance. Okay. So priority is only given for urgent flag. Instead of waiting for the buffer to be full, he will process the urgent flag enabled data first. Then he'll wait for other data until and unless the buffer is full. Meaning what I'm
Okay.
trying to mention is, let's say there's a traffic signal there. Okay. So everyone would be waiting. For example, ambulance arrives. Definitely he'll leave the signal, right?
Mm-hmm.
How about others? They'll stop for
Stop.
sure.
Yeah.
as it is. They have to follow the rules. Without any rules, the urgent flag, meaning a VIP or a president, someone else, you can assume urgent in the same manner. He don't have to go in a queue. That is what is urgent. Rest of them, there is a queue and they have to wait until and unless the queue in front of him is actually processed. The same, this is nothing but a queue only, right? There is a queue, and for example, this person is out, then he'll get the chance. In the same way, one by one this is processed. But whenever urgent is enabled, irrespective of this one, there is a separate channel for urgent. He'll go directly, he'll not go in
Okay.
the queue. That is what is
Okay.
urgent. Now, there would be a question. There has to be a marker on the data, right? From where to where the data is urgent, correct? Or else how
Okay.
would it get to know that particular device, or by the
Yeah.
sender? The sender should mark something, right? From here to here, the data is urgent. So in order to indicate that one, this pointer comes into picture, urgent pointer. From where to where the data is urgent, it will mark that one. Only that data is processed immediately. Rest of the other data will wait for the buffer to be full. Only then they'll be processed. Other data will be processed.
Okay, understood. So it's like by number of bytes or these packets should be processed, right?
You can say a number of bytes from, uh, it's basically a pointer from where to where the data is urgent. Only this
Okay.
data is urgent, for example. Rest of
Mm-hmm.
them, backside and front side, they won't be processed immediately. They'll wait for the queue, and this is for without the queue. It's
Okay.
just like a VIP. You can say that. Okay.
Mm-hmm.
Now we are done with push. We are done with urgent. Okay. Now you know this one as well. What is this window size? I've explained it to you. Okay.
Yeah.
Now we need to understand what is header length, what are reserved bits, what is checksum, and before understanding those things, let me discuss the length of the header. So each row is of 32 bits. Means how many bytes?
4 bytes.
Correct. So each row is of 32 bits. So I believe I have to take this. In this way you can understand better. So from here to here, this is the actual size of TCP header. How much is this one? This is 20 bytes in total. 4,
Okay.
4, 4, 4, 4. 4 5s are 20 bytes.
20
Okay.
bytes.
This is the minimum length of TCP header. Now, These options are extra fields which are actually added if in case if the header is not 20 bytes. Or not only that, we have discussed something about MSS, right? That MSS is inside this options field only. 0 to 40
Okay.
bytes options field. And this is the data which is received from upper layers, meaning layer 5, layer 6, and layer 7. Now, in order to understand it clearly, so we have header length. In header length, how that goes is header length is of 4 bits. 4 bits is equal to 2 power 4. This is how much? 2 power 4, 16, right? So
Okay.
16 is 0 to 15, correct? Now,
Uh-huh.
if I write this value like this, this, and so on up to 50. So here what I'm trying to mention is 5 multiplied by so minimum TCP header length is this much, maximum is this much. Am I clear?
Yeah.
Yeah.
Clear.
But question comes, how did you get this value?
The optional field
Yes,
20 plus
correct,
40.
correct. This options field. Along with 20, if the 40 is added to the maximum, it goes up to 60 bytes, irrespective of data. Data is not included. Okay. Only we are talking about TCP header. After that, we'll include the data. Okay.
Okay.
So this is the size, and it is always the multiple of 4.
Okay.
Fine. Now, okay. This. Now we are done with this part as well. What is length, and we'll discuss about reserved bits. Reserved bits, we have 6 bits reserved. So out of which mm, fourth one, okay, third bit, remaining 0, 1, 2 are Future use. You know what is this one? Okay.
Yeah.
CWR. These two are helpful in
Congestion.
control. Correct.
Okay. Mm-hmm.
In case of this one, so you don't have to worry about these things because these are all reserved ones. And regarding this, to understand this, let me take out the material. Reserved bits and TCP header. Okay, one Varsha capture is taken. One moment. Just this is one thing. So do you know what is RFC exactly?
No, no idea.
Okay. RFC means request for change. Okay.
Okay.
So for each and everything in networking, you'll have an RFC. Okay. Now let me snip it for you. Now, let's see the explanation of these things. So this is basically, this packet capture is the TCP headers packet capture from the Wireshark. Hope you remember in demo class, I have showed a tool called Wireshark, right?
Yeah.
So from the Wireshark, this is the capture. So it is something which looks like this. We have the source port, destination port 23 means he's taking telnet access, which is the remote service. Okay. Now you have the sequence number 0, acknowledgement number 0, which means the traffic is initiated or the data is initiated from the source and he's the source device, correct? We can
Mm-hmm.
identify that. Now, if you look at the flags, this is the SYN message, which is confirm, which confirms that this is the first message which is initiated from the source and he is the source. Now, if you take window size, see what is the by default size?
4128.
Okay, this checksum we'll discuss right now. Okay, now urgent pointer, nothing is urgent right now. Okay, because we are not sending any data in SYN. Remember that thing. After the three-way handshake is complete, only then the data exchange begins. Up till then, we don't have any data inside the SYN. This thing is
Okay.
clear.
Yeah.
Okay. Now, after that, inside options, like the way I told, maximum segment size. See this 1460 bytes, which is
Yeah.
MSS.
Okay.
So this is what is exchanged in what? In SYN flag. Along SYN is just a flag which is enabled. Beyond that, we are sending entire TCP header. Is this thing clear?
Yeah.
Now,
Yes, it's clear.
okay. Now, if you look at the flags over here, see, fin is there, SYN is there, reset is there, push is there, acknowledgement, urgent flag. Then ECN echo, congestion window reduced, nonce, which is not set, reserved, not set. This reserved and nonce are always zeros, which I was indicating just now. Okay.
Okay.
Now, congestion window reduced, you know very well what is it. ECN echo is here. See this thing. CWR is only set to SYNAC to agree to ECN. Okay.
Okay.
Why SYNAC? Because in SYN message, if that device wants to say, I don't support any congestion, and this normally happens in case of server environment where there is a sensitivity. Server is more sensitive device actually in the network. Okay, they have given this additional information. It is not that much important to know, but for simplicity, whatever I have explained should be enough. I have taken this just to make you understand, see the terms which they are using in order to confuse. That's the only thing. Am I clear?
Okay. I mean, not completely about why is CW is set to SYNAC.
Yeah,
I mean,
it is not completely given. You can refer this RFC for complete
okay.
information. You can Google it,
Okay.
you'll find this RFC.
Mm-hmm.
Or else you can Google RFC for TCP.
Okay.
Okay, so this is the thing. Not in complete manner it is given, but it is given for. But as far as what my experience is, according to my troubleshooting part, whenever there is a congestion in the link, only then you'll see this.
Okay.
Apart from this, okay. Now we have seen this reserve bits as well. Inside reserve bits, you need to understand only these two. Which one? CWR is one and ECN is one. Remaining everything is zeros.
Okay.
Now we need to discuss what is checksum. Checksum is nothing but the source device. For example, A is the source. It will apply some algorithm I'm assuming this cone to be an algorithm. What algorithm it will apply? Any something it is called CRC algorithm. Any algorithm it may apply. No one knows which algorithm actually it applies. This is something which is done in the coding part, and we are not here to actually dig into coding. Okay. So this is some algorithm which is applied on what he is applying algorithm, whatever the data or whatever is exchanged, whatever the message it is exchanging, whatever the header it is exchanged. Okay. Once it is put into this one, he'll generate some value. That value might look something like this. Any value, for example. Okay. This is called hashing, this process. Okay, wherein it is called as checksum. What it is checking is whether there are any errors in the data. So what it is doing is it will attach the same with the TCP header. Let's say this is TCP, and along with the TCP, it will attach this part, meaning and it is sent to destination device. Again, what destination will do is destination also will do the same thing. It will just separate this one firstly. Okay, he'll put this value here. He'll match these two values. Which two values? The output which he got with the one which is sent by the sender. If these two values are matched, then there are no errors in the data. Why is he doing so? Because he, he is suspecting that anyone can modify the header in between. Am I clear?
Okay.
For each and every header, there is a checksum involved.
Okay.
Not as a whole, but individually to each and every header. Am I clear with this part?
Mm-hmm. So the receiver also run the same algorithm
Yes, same
and
algorithm.
okay.
Whatever the sender has run, he'll also run the same algorithm. Okay,
Okay.
is this clear to both of you?
Yeah, it's clear.
Fine.
Yeah, it's clear. I
Okay.
can understand.
Now this was all about checksum. And if we talk about options, there are some options which you need to be familiar with, out of which one important option is MSS. Okay, this you know this thing, MSS, that's for sure. We have types of acknowledgements. In case of TCP, we have two types of acknowledgements. One is The other one is so now by default TCP uses cumulative acknowledgement. Now, what is the difference between the two is again I am taking the same example. For example, there are segments sent. Okay, so this is for example segment 1, segment 2, segment 3, segment 4. For example, segment 3 is lost and segment 5. Now it will keep on storing the segments as soon as those are received. Now segment 3 is lost in between. What happens is it won't store the remaining segments which are received. It will keep on dropping those segments. Reason why? It follows ordered storing of the buffer. Ordered in the sense he needs the data in correct order. If let's say without receiving segment 3, if I receive segment 4 and 5, I won't accept it because somewhere the order will mismatch. Okay. So this is what is called cumulative acknowledgement. Am I clear?
Okay.
Now what he will acknowledge is, and in case of cumulative acknowledgement, there is a formula, if you remember. What is that
Uh,
formula? Acknowledgement number equal to sequence number
six plus one.
plus 1, correct? So for each and every segment, there is a sequence number and acknowledgement number, right?
Mm-hmm.
So what he will do is, for example, if you consider this as some sequence numbers, then what he will do is, for example, sequence number 1 is done, 2 is done. Then next expected sequence number will be 3, right? So what he will
Yes.
acknowledge is acknowledgement number equal to 3.
Okay.
Now, upon reception of this acknowledgement, what the sender will understand? I have sent up to 5,
Fine.
but he is
Mm-hmm.
sending acknowledgement 3, which means that from 3 he didn't get any segments which I have sent. So what he'll do, he'll retransmit again. Okay, he'll retransmit 3, 4, and 5. Am I clear?
Yes.
So segment 3, 4, and segment 5. So once these are retransmitted, now he'll store 3, 4, and 5. Now he'll acknowledge what? Acknowledgement 6.
Six. Okay.
So next expected is 6, right? So what is happening here? Bandwidth is being utilized and retransmissions are happening. Am I clear?
Mm-hmm.
In case of what? In case of cumulative acknowledgement.
Cumulative. Okay.
And what is the difference in selective acknowledgement is, again, I'm considering the same example. Now, the same way, if the segment is lost, this time he'll accept that one. Let's say segment 1, segment 2, segment 3 is lost this time as well. But segment 4 and 5 are sent. So what he'll do is he'll accept segment, he'll leave the space for segment 3 and he'll accept segment 3, sorry, segment 4 and segment 5. Now what acknowledgement he'll send is, in this case, in case of selective acknowledgement number is equal to sequence number. Am I clear or not? There the formula is different. Where in case of cumulative acknowledgement, this only works for which acknowledgement? Cumulative.
Cumulative.
Okay, but in this case, acknowledgement number is equal to sequence number. This is for selective. Am I clear with this thing? Now what would be the acknowledgement number which he is sending? So he'd send, he has accepted segment 4 and segment 5, right?
Mm-hmm.
So you can consider it as segment or you can consider it as sequence number. Reason why I'm mentioning in that manner, because to each and every segment there is a sequence number, right?
Yeah.
So definitely, whether it is a segment or whether it is a sequence number, both
Sequence.
are similar in this case.
Okay.
So now for ACK, he'll send ACK equal to 3, which means that 3 is not received. Like I said, sequence number is equal to acknowledgement number in case of selective acknowledgement. Am I clear?
Okay.
After that, he'll send what? ACK equal to 6. So
Okay.
by seeing these two, he'll understand. Okay, 4 and 5 also he accepted, which means 3 is lost in between. And next is 6. I'll send 3 and 6. 3 would be retransmitted. From 6, it is sending as it is. Is this thing clear or any
Okay.
confusion?
No, it's clear.
Both of you?
Yeah, like sequence plus 1 is also 3, right?
No. You,
Like in the previous example.
in the previous example, that is related to what? Which type of acknowledgement?
Cumulative.
So in case of cumulative only, this formula works. But in case of selective, this formula works.
Okay.
So if
Yeah.
segment 4 also lost, then acknowledgement will be sent as 3 and 4, right?
Correct.
3, 4, 6, right? Okay.
3, 4.
Yeah. Your ACK will be sent as 3, 4, 6.
But in the cumulative case, it only sends 3.
Correct. It won't. It is not accepting remaining, right?
Remaining,
So that's the reason why it is set to this one. But here in this case, it is accepting.
Okay.
In case of selective acknowledgement. Are you clear?
Okay. Yeah.
Okay.
Yeah, it's clear.
Fine. So this was about the acknowledgement part. Now, one more thing. So by default, it is using this one. Why is it not using this one? There might be a question. If you use this one, this is in the options field inside TCP. So what happens if you use this one? Header size increases. Am I clear? TCP header size increases. By default, it is what? 20 bytes,
Okay.
right?
20 bytes, yeah.
So if you're adding on options, then it would be increasing. Now, like I have mentioned something, TCP header is always the multiple of 4. What if it is not the multiple of 4? Padding is done. Padding is nothing but adding some data to make it round figure, you can say.
Mm-hmm. Okay.
Okay. Round figure of what? Round figure of multiple of 4.
Multiple of 4. Okay.
Is this thing clear?
Yeah.
By using what it will do padding? By using options only, it will do padding. Okay. This padding would be done in any layer where the multiple of 4 will be there. Why multiple of 4? Because of uniform size. Okay, because they want the header to be in uniform size. That's the only reason why it is that part. Okay, is this thing clear?
Okay. Yeah, clear.
Now, what else is left in TCP header? Now, next comes the data part. Anyhow, you know what is data, which is coming from upper layers, normal data. Okay,
Mm-hmm.
so this is the thing. This is all about TCP header. Now, we'll start with IP. Network layer. Network to network delivery of data. Meaning, okay, to take the data from one network to another network. And this is done by routing is done by layer 3 device called router. Am I clear?
Yeah.
Yeah.
Now, in this, there is only one protocol which is involved, that is IP. IP stands for under IP, we have two versions. IP version 4 and the other one is IP version 6. So IP version 4 is of 32 bits. Okay. IP version 6 is of 128 bits. I mean, am I clear? Address length of IPv4 is 32 bits. Address length of IPv6 is 128 bits. Okay.
28.
Now, mm, so IPv6 address is separated by fields, whereas IPv4 address is separated by dots. Now, we'll discuss a concept called fragmentation. Okay. Now, fragmentation is similar to segmentation. What exactly happens in fragmentation is dividing the data into multiple fragments is called as fragmentation. Now, in order to understand this concept, I have a very good example. Let's say I have a PC. For example, I have two PCs. For now, I'm considering only routers. Okay. Now, I'm sending this message, which is of 5,000 bytes, for example. Okay. Now, before going to this one, this example, I would like to mention over here, there might be a question, what is the size of uniform division? So that size is given by MTU, and this MTU stands for, okay, maximum transmission unit.
Okay.
What what is the definition of it is, before going to definition, now, so this thing is clear, it is 1500. So 1500 is the value of each interface. This interface is 1500, this is 1500, this is 1500, this is 1500, which means I won't allow any data greater than 1500 bytes. Okay, to pass through an interface.
Okay.
Now, but while receiving, he will receive. When he'll actually check that MTU is while sending. Am I clear?
Yeah.
Okay.
Now this 5000 bytes are received over here. He won't check this interface MTU. Reason why, he has received it. When he's transmitting from this interface, okay, he will check the MTU. What is my MTU size? What is the data size? Okay, this is 1500. So I need to fragment this data. Now, in order to fragment that, what he'll do is he'll mark high into one fragment, R into one fragment, U into other fragment, and question mark. Then how into one fragment, for example. Now, these fragments are mismatched in order, right? So there are two fields in case of IP to identify that all the fragments belong to same packet. So that is marked with identification field. For example, I'm marking 1. So this 1 means I'm indicating that all these fragments belongs to the same packet. Now, what is this one called? This one is called as, am I clear? Identification field. Now, in order to match the order, I'm giving these values 0, 1, 2, and 3. So for this one, this is called as now. I hope you can define this and this.
Okay.
What is identification field? It helps to identify that all the fragments belong to the same packet. In the similar manner, what is a fragment offset? Fragment offset helps to arrange the fragments back in correct order at the destination.
Okay.
Am I clear?
Mm-hmm.
So that is where the ordering is defined. Fragment offset means. So let me indicate this with this manner, then it will be fine. Now, for this one, I will indicate it this one. It is clear, right? You want me to type it, the definitions?
No, no, that's clear.
It's clear.
Okay. So this is all about the thing. Now, I was using the term packet, right? In case of network layer, the data is called as, okay. In case of transport layer, am I clear?
Okay.
So here the data is called as packet,
Right.
and
Packet.
there the
Okay.
data is called as segment.
Okay.
Now, this being said, there's a field called TTL inside IP header. TTL means time to leave. On each layer 3 device, TTL is decremented by 1. Now, the TTL values for Windows PC, Windows operating system, the TTL value is 128. For if it is Linux operating system, the TTL value is 64. If it is Cisco device, the TTL value is 255. So basically, what I was mentioning here is, for example, there are layer 3 hops involved, layer 3 devices. Now, this is my PC and this is my destination PC. So from here to here, let's say, now, like I said, my TTL is 128 here, but once it comes here, it would be 127. Then, then, so here the TTL would come as 124. Am I clear? Only on the layer 3 device it is decremented. PC will not decrement any TTL.
Okay.
Now, practically, if I would like to show you how this is decremented, one moment. Man, where is the screen? Just a moment. Let me open the command prompt. Yeah. Which screen is visible to you?
Command prompt.
Okay. Now, in this, if I'm generating a ping, for example, to Google public IP address. Now I'm getting some reply. There you are seeing some TTL value, right?
Yeah.
What is that TTL?
114.
114. What I've told the TTL for Windows?
128.
So 128 minus 114. How much?
14.
14.
So my device, which device? 8.8.8 is how many hops away?
14.
Hops means nothing but devices. Hops means nothing but layer 3 devices. Am I clear? How am I saying this? Because my TTL will be decremented by 1 on every layer 3 hop. Hop means HOP, hops. Basically, they'll call it as hop. Okay.
Okay.
Is this thing clear?
Yeah.
Yeah, clear.
Okay. So this is how practically you need to calculate. Uh, there might be a question. Let's say I'm getting TTL this much value. How many hops away my device would be? So in that case, you need to first ask a written question. What is the operating system which you are using? If it is Windows, the TTL is like this. If it is Linux, the TTL is like this. Basically, the calculation remains same. Am I clear?
Okay, so um,
Go ahead. Some question you are asking.
yeah, actually, so whatever the device prepping, it's less than 64. I mean, number of hops, because Linux has only 64 TTL, right?
See, the answer for your question is very simple. What is the hope value which we got here?
14.
Now, I mentioned 128. Where is 128 and where is 14?
No, okay. But for Linux, it is only 64, right?
Correct, only 64. But I believe in case of Linux, what happens is the device will not be, for now you are getting TTL 124, sorry, 114. If in case Linux has TTL 114, what you will do? Is that what you're asking?
No, no, no. If the server is more than 64 hops away,
You won't find that case at all.
okay, okay.
Do you think Google server is very near?
No, no, no. Not about the Google server. Any server.
Any server you consider
Like
in the
if
whole
I
world. Okay,
okay,
what I'm trying to say, in the whole world, any server you can consider, that will not be more than, am I
okay,
clear?
okay then. Mm-hmm.
More than 30 hops away.
Okay, it's clear. Yeah.
Now let me stop the screen share. Let me share you. Where is my paint open? Now let me explain you what is IP header. In order to check that IP, similar to TCP header, IP header also have the rows wherein each row should is of the length of 32 bits, which means 4 bytes. So it is a clear indication that IP header should also be the multiple of 4 for sure. And also IP header range is similar to TCP header. Minimum length of IP header is 20 bytes. Maximum length of IP header is 60 bytes if it is inclusive of options. Is this thing clear?
Yeah, clear.
So out of this, you're clear with this part, I believe. Just this one, right? Just now I have
Mm-hmm.
explained. Also, you're
Yes.
clear with this thing.
Identification. Okay.
Also you're clear with?
Mm-hmm.
Also you know this. You know this, right?
Yeah.
Now, we need to understand this is nothing but version means IP version 4. Okay. Header length. According to me, I have explained this to you already. Am I correct?
Okay. Yeah.
Now, these are the flags. Only 3 flags involved. 0 is for future use. We don't care about it. DF means do not fragment or don't fragment. Okay. MF means more fragments. Where that example, sorry, to which example this is being related is I've explained you something called fragmentation, right? So what happens is on each and every fragment there is a flag set wherein, for example, I'm sending how MF is 1, which means more fragments are coming. For example, hi. For hi as well, I'm setting MF is 1. For R as well, setting segment, I'm setting the flag MF equal to 1. For U, what will I do? MF equal to 0. Why? Because I don't have any other fragments. This is the last fragment. Am I clear?
Okay. Yeah. Clear.
More fragments means this one. Now,
Okay.
what is don't fragment? Don't fragment is if don't fragment is set to 1, that means please don't do any fragmentation irrespective of the data size. Am I clear? Now, there might be a question how the data is sent. If more sized data, if let's say the data size is 5000 bytes, wherein MF is set to 1, sorry, DF is set to 1. In that case, what happens is the data is directly dropped. The packet is dropped directly. Why? What is the
Okay.
reason for the packet to be dropped? Data size is coming more. My MTU is this much only 1500 bytes I can allow. Because of the data size is high, I need to do fragmentation. But since do not fragment is set, I am not supposed to do any fragmentation. So that data doesn't have any permission to pass through my interface. Am I clear?
Mm-hmm.
So
Clear.
I am not authorized to fragment that data. So that is the reason why I'm dropping that data. Okay.
Okay. Mm-hmm.
So this is what is do not fragment. More fragment means more fragments are coming. Do not fragments means please don't do any fragmentation, even if the data size is more. Okay.
Okay. Clear.
Now let's get back to our scenario. Now I've explained this as well. Sorry, if I remember right. I told you every header will have checksum.
Check some. Okay.
This is done, this is done, this is done, this is done, and this is also done. Now, total length, what this total length is saying is, what is the maximum length IP header can go up to? Total length means what? Including what? Including
Data. Okay.
data. How much length it can go? 2 raised to the power 16, which is 65535. Am I clear?
Oh yeah.
2 raised to the power 16, which is 65535, which is my total length, including data. Is this clear?
Okay.
Now, this is also done. we'll discuss what is protocol here, which is of 8 bits. Protocol means so type of traffic means type of data. Technically, it is called as traffic. Am I clear? What is the type of
Yeah.
data? From upper layer, network layer has got this data. From upper layer, from which protocol he has got this data? If he has got the data from TCP, the value is 6. If he has got the data from UDP, the value is 17. Am I clear?
Okay.
Depending on this value, he'll get to know what type of data is there and who has encapsulated the data in the upper layer. Am I clear?
Yeah, it's clear.
This will not be helpful at the source end, but this is definitely helpful at the destination end. What
Destination.
happen? What happens at the destination end is decapsulation. Decapsulation means unwrapping. Whenever that is unwrapped, whatever leftover data he has to hand over to upper layer, right? Reverse process.
Mm-hmm.
So whenever he has unwrapped or decapsulated the data in network layer, he will have remaining data, right? Once he has opened his header, he doesn't have the right to open TCP header. He has the right only to open IP header.
IP header. Yeah.
Now, TCP header will be opened by transport layer. So in order to give it to transport layer, to which protocol he has to give. So depending on this information, he'll get to know to which protocol he need to hand over the remaining data, whether I have to hand over it to TCP or whether I have to hand over it to UDP. If it is 17, then I'll hand over it to UDP. If it is 6, then I'll hand over it to TCP. Is this thing clear or any confusion?
Yeah. Are
Yeah,
there
it's
only two
clear.
or there are any else like
There
number?
are many others,
Okay.
many others as well. But for now, I am taking only 2.
Okay.
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 So for now, you understand it like this. Okay. Now, we'll go into more detailed discussion in the forthcoming sessions, but for now you understand it in a simple manner, like the way I have mentioned it. Okay. Now we have this part called type of service. So this type of service, let me take out the material for you. Okay. Now hope you're able to see this thing, right?
Yeah.
Yeah.
Okay. Now type of service in depth is indicated by this particular field, these fields in this box. Okay. Now, firstly, we'll start with precedence. What does this precedence says? There are certain priorities given, and these are all you can say the reserved categories. Okay. For example, let's say I'm using prepaid SIM card. Okay. You are using postpaid SIM card. So the service facility is different for you and me. In what case, for you, the customer service will respond with priority, means more precedence is given to you than me. Reason why? Because you are the postpaid customer, right?
Okay.
In the same manner, if I'll bring, Mukesh Ambani, right?
Mm-hmm.
For his SIM card, what do you think the priority would be?
The highest one.
He's, yeah, he'd be in extreme level, right?
Yeah.
So that is what is called as critical. We are under these categories somewhere. Now this is
Okay.
reserved for inter-network control and network control by network engineers, some networking processes. Apart from this, these are all used by us. Okay,
Okay.
priority, immediate, flash override, these things and all. It is exactly similar, and these are the binary values. Okay,
Mm-hmm.
now type of service bits are these bits: delay, throughput. You know this, right? What is delay? What is throughput? Throughput means maximum processing capacity of the device. What is my incoming packets? What are my outgoing packets?
Uh-huh.
Reliability means you know this thing, right?
Okay.
Cost means it is all about pricing or something like that, which is beyond the case. MBZ means checking each and every bits. But one important note, what is mentioned here, see?
Okay.
And one more important note, study once you read this. Okay, no one really asks what is this exactly. Am I clear with this?
Okay.
Just at the back end, this actually happens. Just to know what exactly happens, I'm explaining it to you.
Okay.
Am I clear?
Mm-hmm.
If
Yeah.
you want to study more, again, you can by going to this. But it is of useless. But it is up to you. Again, if you want to study these things, you can go to these RFCs and you can refer. No worries. Fine.
Okay.
Now, this being type of service. Reason why I don't remember these things is because of this thing only. Main reason is it won't be used anywhere in the troubleshooting part. Then what is the requirement to store this data, right?
Yeah. Yeah.
So that is the reason.
Okay.
Now, if we discuss about options, there are some fields definitely in the option. What are those fields is now I would like to show you. One interesting thing. Is this thing visible?
Yes, it's visible.
Okay. You can see for what the options is used for here. Last but one. Testing,
Okay,
debugging, and security
security.
purposes. Now again, there is a padding involved.
Mm-hmm.
Why is it involved?
To round up to 4 bytes.
Correct. See this.
Okay.
Okay, that's all. This is done. Is anything left over? I've told everything, right?
Mm-hmm.
In the IP. This is the total length which I was mentioning. This is identification. Flags. 0 means reserved. 1 indicates whether the datagram would be fragmented or not. MF.
Okay.
Fragment offset is for reassembly process at what? Destination device.
Destination, yeah.
Okay. TTL I have explained you. Protocol also I have explained you. Okay. You are talking about remaining, right? These are the remaining. IGRP, Interior Gateway Routing Protocol. OSPF is Open Shortest Path First. ICMP is Internet Control Message Protocol. You learn this, no worries. But since these are new to you, I haven't mentioned these things. Okay. Now header checksum I've already explained, which is for error control for the header only for header, not for any data.
Okay.
So one important thing to remember here, IP header with options is called as an attack packet. TCP header without an options is called as an attack packet. Am I clear with my
Okay.
lines?
Uh-huh.
Reason why I'm mentioning so? Okay, let's start from TCP. Reason why I mentioned that TCP header without options is an attack packet.
I'm not sure.
MSS is there in the option, right? As at least
Yeah.
it should have MSS, right?
Yeah, yeah.
Then without option, how come it'll actually do? Am I clear?
Okay.
Now,
Like, what's an
So,
attack packet?
attack packet is malicious packet. Simple thing.
Okay.
Which is gonna create some outage or something which is gonna misuse something or steal something. You can say malicious packet. Am I clear?
yeah, so if there is no
Yeah,
MSS
clear.
in the TCP packet, so
And moreover, one more thing. What do you think? How did you get MSS as 1460? Any idea?
no.
No ways. So, what is the value of MTU?
1500.
Okay. Now, what is the value of TCP header length minimum?
20.
20 bytes.
What is the value of IP header minimum?
20 bytes.
20.
Now, is this thing clear?
Mm-hmm. Yeah, it's clear.
So that's why MSS is of fixed size.
Okay. So if there are optional fields included,
What optional fields?
like in TCP, if the optional fields are included, then the bytes increase, right?
Correct.
So then the IP defragmented, like,
One thing to be understood by you is if already segmentation is done, right?
okay,
Any idea?
so
Is this question making some sense?
yeah, but if the IP data goes beyond 1500, then
How will it go 1500 beyond when it is 1460 only? Correct or wrong?
okay, so MSS is 1460 is data bytes, right?
Correct.
Yeah, and TCP header is from 20 bytes to 60 bytes, right?
Correct.
Okay, so if there are optional fields included, then the TCP date, I mean, the IP data field may go up to like 1520 or something. Only the data, IP data.
You have forgot something. What I told, when the data exchange will happen exactly, if I consider TCP,
Uh,
directly will I exchange any data?
since like
Using routers.
In in between any device, um, will I exchange data directly?
um,
I have to make connection, right? By using what?
yeah, uh, uh, like TCP handshake,
Three-way
like
handshake.
three-way
Correct.
handshake. Yeah. Uh-huh.
So do we have any data in three-way handshake?
No.
Then what I am trying to say you is it's very simple. Firstly, what I am doing, what I have done, I made a connection. Correct.
Okay. Uh-huh.
Inside the connection, what is happening?
Data transfer.
Then do I need to have any uniform size? Already my uniform size is outside, right?
Okay.
Am I clear? My device will understand what? Inside anyhow uniform size would be there. But I am talking just to avoid your confusion of this fragmentation and segmentation.
Okay.
So outside
So
view is what? This doesn't have any data. So
data.
this is all about SYN packet, which is exchanged at what? Standard values of 1460 and 1500. Am I correct?
Okay.
Now, inside this only whatever is happening, correct?
Okay.
Inside this, I am sending segments, each of 1460. If the data size is more than 1500, I am fragmenting and sending it as 1500 bytes each.
Okay.
Okay. Now, To answer this question, if already segmentation is done, what is the requirement of fragmentation is, if let's say the traffic is generated in layer 3 itself without the involvement of layer 4. For
Okay.
example, if I consider ICMP, ICMP is not layer 7, it is layer 3 protocol.
Yeah.
So if I am generating ICMP, how will I control this part? ICMP data. That should also be controlled, right?
Yeah. Yeah.
So in order to control that, fragmentation is there. What I told, there is another protocol in transport layer, which is UDP.
UDP
UDP doesn't have any segmentation,
segmentation.
fragmentation concepts. It is just like fire and forget. It doesn't have any uniform size. Okay.
Okay.
So if I'm using UDP, then I would require what?
Fragmentation.
So that is the answer for this question. Am I clear?
Okay.
And coming back to your thing, what you're saying is it might also be variable. You're saying it will be variable, but not in all the cases. By default size is this much only. Wherever you take the packet capture, you'll find only this much size. Am I
Okay.
clear?
Mm-hmm.
If you're finding more size, that more size is only due to one thing, one exceptional case. That is jumbo frames,
Okay.
wherein 9,000 bytes of, but one important condition as well. Each and every device should support that jumbo frame in your network. Only then this jumbo frame exchange is possible.
Okay.
Am I clear?
Mm-hmm.
And what is the device which is responsible for generating jumbo frames is Nexus switches. High-end series switches of Cisco company. Okay.
Okay.
Just to make you understand, I'm taking this example. Okay.
Mm-hmm.
Is everything clear or still any doubts?
No, no, it's clear.
The more you dig into it, the more you'll be clear in the
Okay.
concepts.
Yeah.
But right now, if you dig into it, you'll be confused.
Yeah. Okay.
I have all the answers for your questions. Whatever you ask, I'll be able to answer. I'm definitely sure about it
Okay. Sure.
because I have gone to last level of troubleshooting in each and every concept, where it is used, whether it is really in use or not. I'm pretty sure about it. Okay. So that's the
Okay.
reason why I have that confidence that I can answer that. Okay.
Okay. Sure.
Any other doubts?
No.
Not right now.
Okay, no worries. So what's the time? It's 19:55. Still we have 5 minutes. You can ask whatever you want in this 5 minutes. Hope all these things are clear to you, right?
Yeah.
And one more thing I forgot to ask you. Am I going too fast?
No, no, no. The pace is fine. Like the speed is fine.
Okay. Not
Okay. For windowing, it's 4128 bytes, right? Is there
correct.
something like related to this?
Related to what?
Like MSS, some formula?
No, window size is not at
Okay.
all related to anything. That is the
Okay.
reason why it is variable, right?
Yeah.
Why MSS is fixed? Because MSS is dependent on what? It is dependent on MTU at the network layer.
MT. Okay.
Mm.
You need to put a question why, only then you'll understand. In starting itself, I mentioned that. Am I clear?
Yeah.
Okay.
Mm. Any other things, please let me know among the concepts which I've already discussed. If not, we'll wind up. What do you say?
I
Yeah,
guess we can wind up.
yeah.
Sure, definitely. Again, please revise it. Okay, only then you'll understand. Like the way I mentioned, as usual. Okay.
Oh, sure.
Yeah.
Okay, then have a nice day. Bye bye.
Bye.
Thank you. You too
See
have a
you.
nice day. Bye.